All right, let's keep going with chapter 9. 9.2, we're introducing arithmetic sequences and partial sums. So, when we have a sequence that is addition, where every step in between is a +3 or a +5 or a +7, we call those arithmetic sequences, right? Arithmetic, when we're adding, right? So if the difference between consecutive terms is the same, we have the arithmetic sequence, all right? And then the difference between the numbers, if we're jumping by 3s or jumping by 5s, that's what we call the common difference. All right, so knowing that, let's look at a couple examples. If the sequence whose nth term is 4n plus 3 is arithmetic, okay, for this sequence, the common difference is going to be 4 because we're jumping by 4 each time. So if we plugged in 1, we get 7. If we plugged in 2, 4 times 2 is 8. 8 plus 3 is 11. Plug in 3. 4 times 3 is 12. 12 plus 3 is 15. All right, so what's the gap between these? 7 to 11 is 4. 11 to 15 is 4. 15 to 19 is 4. So we have a constant common term, and that's 4. All right, the common difference is 4. First term is 7. All right, so if we look at this one here, 7 minus 5n, the common difference is going to be -5. It's the multiplier each time. For this one here, the common difference is going to be a quarter, because if we distributed the 1/4 in, it's a 4th n. All right, so anytime it's a multiplier times n, we're arithmetic, and we'll be jumping by some common difference. So knowing that, see if you can do problem 5. Okay, so now we do have a formula here to figure out any nth term of an arithmetic sequence, and that is take your first term, go n minus 1. So if we're trying to figure out the 20th term, we're going to plug in 19 here. 19 times d. And the reason it's n minus 1 is because this is how many jumps it takes to get from the first number to, let's say, your 20th number. If we're trying to go from the first number to your 20th number, we would need to have 19 increments, 19 more jumps, each with a common difference. So let's see if we can do a problem here and see if that makes sense. Just a study tip, this was in the book, I kind of like this here. A2 is going to be A1 plus 1D. A3 is going to be A1 plus 2D, right? A5, A1 plus 4D. So we can see why it's always 1 less here than the n. So let's plug this in, find a formula for the nth term of the arithmetic sequence whose common difference. I'm going to write D is 3, and the first term, A1, is 2. So let's just plug it straight into our formula. The nth term is the first term plus n minus 1 times D times 3. Let's just distribute here and we'll clean it up. 3n, right? The 3 is going in there, minus 3, and we're going to get -1 plus 3n, or 3n minus 1 for a sub n. Okay? Now, sometimes it's going to be helpful here. What we could do here, this formula is also the same as, you'll notice when we distribute here, it's going to be right here. This is the same as saying dn a1 plus dn minus -3 right here. When we're jumping that in, minus a d. And so you can combine that with your a1. So really what we're looking at is if you can figure out the 0 term, the term before, which would be starting with 2 minus 3, that's -1. That's always going to be here. So another way to get this formula is a sub n equals dn plus a0. All right, so an alternate form, dn plus a0. All right, use either one of those forms there and see if you can do problem 25. All right, fourth term of an arithmetic sequence is 20. The 13th term is 65. So let me write these down. Let's see, fourth term. A4 is 20, and A13 is 65. All right, so we have to ask ourselves, how many jumps have we made to go from 4 to 13? So 13 minus 4 is 9. Okay, so 9 intervals and we changed from 20 to 65, that's a jump of 45. That's an increase. So if we increased 45 over 9 intervals, we could say 45 divided by 9 and get a jump of 5 each time. So each jump, each interval is worth 5. This is the same as doing slope. y2 minus y1 over x2 minus x1. Okay? So we're just finding the change in y for every change in x. So now that we have d, we want to find a sub n. So for that we need a1. So let's go to our formula here. A sub n equals a1 plus n minus 1 d. All right, so we don't have a1, but we do have an an. We have, let's use this one here. We have a value of 20 when the n value is 4. The fourth number in the list is 20. We know the d as well. We know d is 5. We can use that to figure out the first number in the list. So we say 20 equals a1, and then 3 times 15, and minus 1, 15. That's right. Okay, just checking my numbers there. So we'll subtract. So 5 equals a1. And now that we know a1, let's go back in here and just clean this up. Let me create a little space here. Okay, and so we've got an equals a1, which is 5, plus n minus 1. The jump was also 5. And so we've got an equals 5 plus 5n minus 5. So an equals just 5n. That's our formula. Sometimes here it's going to help you to make a little chart, which I think is the study guide here in the book. Erase this so we can see it. Okay. And, oh, no, that's just the same thing that we were doing. But that's helpful. If you look back in the book here, if you ever get confused on this one, nice little step-by-step is written in the book. So you can look back in there and check that. All right, knowing what we just did, see if you can do problem 39. All right, so if you know the nth term of an arithmetic sequence and you know the common difference, you can find the n plus 1th term by using the recursion formula. So new formula here, recursion. The next term in your list is going to be your current term plus the difference, plus the common difference. All right, so with this formula, you can find any term of an arithmetic sequence provided that you know the preceding term, right? So if you know a number and you add the difference, you're going to get the next number. So let's find the 9th term of an arithmetic sequence that begins with 2 and 9. So on this one, we've got our n, the first number, and we want to find the 9th term. So we're going to go all the way out to 9. 3, 4, 5, 6, 7, 8, 9. The first number in our list is 2. The second number is 9. What did we jump by? We jumped by 7. And we know we're adding because it's arithmetic. So now let's add 7 again. Plus 7 to 9 is 16. Let's keep going. 16 plus 7, 23. Plus 7, 30. 37, 44, 51, and 58. All the way down there. So we can use that recursively. All right. We could also do this just coming up with probably a lot faster here. A sub n, here's our formula, equals a1 plus n minus 1 times d. We know the first term is 2. We know that the difference is 7. So what do we got here? 2 plus 7n minus 7, or 7n minus 5. That's your formula for a sub n. If we wanted to know the 9th term, a 9 is going to be 7 times 9 minus 5, 63 minus 5, 58. All All right, so we can do it recursively, and we can just do it with the normal formula. All right, so either way you want to do it, see if you can figure out the 10th term of this list on 47. And you'll see here that the answer, they don't do it recursively. They do it by using the formula. Okay, so now what if we want to do sums? What if we want to add them all together? Well, we have a nice little formula here. N over 2, the first number and the last number. And what we can do with this, what this comes from, is a nice example here. This is an example. I want to use this example real quick. I want to say add up the numbers 1 to 10. All right, so I'm going to write that as a list. 1, 2, 3, 4, 5, 6, 7, 8. Do I have room? Yes, I do. 1 through 10. And here's what we want to do. Let's look at the outside numbers. What's 1 plus 10? It's 11. What's 2 plus 9? It's 11. What's 3 plus 8 is 11. 4 plus 7 is 11. 5 plus 6, they're all 11s, right? So the outside pairs are going to make the same sum. Then you just have to, so that's what this part is. The first number plus the last number, 11. Then you have to say to yourself, all right, how many pairs are there? Well, if I have 10 numbers, if I divide by 2, that's this part, then we have 5 pairs. 5 times 11 is 55, right? So we're going to add up the outsides. If we add 1 to 10, we get 55. So what's our outside here? 1 plus 19 is 20. How many pairs do we have? We've got 1, 2, 3, 4. We've got 5 pairs of 20. So our answer here is 100. All right, so that's the formula you can use to get the sum there. See if you can figure it out for 51. All right, find the sum of the integers from 1 to 100 and from 1 to n. So same thing we were just doing here, from 1 to 100. 1 plus 100 is 101. And how many pairs are there? There are 100 divided by 2, or 50 pairs. 50 times 101 is, what do we have here? 50 times 100 would be that, plus another 50 is 5050. Okay? And what about from 1 to n? All right, so same thing. How many pairs are we going to have? We're going to have n pairs. And it's going to be 1 plus the last number is n. All right, so it's going to be n over 2 plus n squared over 2, or n plus n squared all over 2. The sum of any 1 to n integers. All right, so there's a nice little formula there. See if you can do it for the sum of the first 50 positive even integers. Okay, and let's find the 150th partial sum of this arithmetic sequence. So this is saying we're going to find the first 150 numbers and add them up. All right, so we can use the same formula we've been using, but we do need to figure out what the 150th number is. So the 150th number, we're going to use our first formula we've got. The first number on the list is 5, plus n minus 1, and, plus 150, we know what n is, 150 minus 1, times, what's the jump here? 5 to 16 is plus 11, so times 11. So this is 5 plus 149 times 11. And let's see what we got. 149 times 10 is 1490. And then plus another 149. 9 and 3 and 6 and 1. And then plus the 5. So we got 1644. All right, so that's our 150th number. So now what's the sum of those? So let's use our formula. 150 numbers. So we can write sum of 150. 150 numbers split into pairs, so divide by 2. the first number is 5. The last number is 1644. So it's 75 times 1649. And this one we'll go to the calculator for. Let's see what we get here. 75 times 1649. 123,675. 123,675. So you'll notice here we used both formulas. We used the a sub n formula to figure out the 150th number, and then we used the sum formula to add them all up. See if you can do the same thing here on 69. All right, 2 word problems here to wrap things up. We got a golf tournament. 16 golfers with the lowest scores win money. First place gets 1,000, then 950, then 900, and so on. What's the total amount of prize money? All right, let's pull some things out here. A1 is 1,000. We have a common difference here of -50. We're going down by 50, and we have an n. N is 16. That's how many golfers there are. And we want the summation. Now we're ready to go here and plug it in. First we need the last person who wins money is going to be the first person, 1,000 plus n minus 1 times the difference, -50. So 1,000 times plus 15 times -50. And that's going to be 750, so we get 250 here. So the 16th person gets $250. And so let's put this together in our sum formula. The sum of these 16 winners are 16 pairs. 1,000's our first number. 250's our last number. 8 times 1,250. And that's going to be 8 times 250 is 2,000 plus another 8,000. It's going to be $10,000. $10,000 in prize money here, split between 16 winners. Use the same thinking for 97. All right, last one. Let's wrap this up. Small business sells $10,000 worth of skincare products during the first year. All right, we want to increase sales by 7,500 every single year for 9 years. Assuming we meet our goals, how many sales do we make during the first 10 years? Okay, sales all together. So we know a couple things. Let's pull them out. A1 is 10,000. D is 7,500. And N here is going to be not 9. Don't fall into this trap. N is going to be 10 because it's 9 years on top of the original first year. All right, during the first 10 years total. So let's figure out how much you made in the 10th year. Is going to be 10,000 for the first year plus n minus 1, 10 minus 1 times 7,500. So 10,000 plus 9 times 7,500. And what's 9 times 7,500? Getting lazy here. Plus the 10,000 to start with. So in year 10, he's making 77,500. Let's find out how much he made total in those 10 years. 10 pairs, so 5. First year was 10,000. Last year was 77,500. So we're going to have 5 times 87,500. Let's multiply that out. There's our 87,500 times 5. And he would have made $437,500 during those 10 years combined. So not too bad for his skincare products. See if you can figure it out for the snow plowing company, how much money he's going to make. Figure that out, and that's it. And we're all done with 9-2.